Um, Good afternoon again. We still on general solutions. Now it's part 2. On the board here, I've got activity number 2. Now on the question, they say find the general solution of cos 2 theta plus 4 sine squared theta minus 5 sine theta minus 4. So looking at this question or the equation that is given, we always try to check the dominating spelling there. We always check the dominating. What is our dominating ratio in this case? So if you check on this question, term number 1 is cos, term number 2 sine, and term number 3 sine, but term number 4 is a constant number. So this shows that of all the terms that are given here, we have got sine that is a dominating ratio. So in this case, it means that our dominating ratio is sine. Now, the second thing that we are going to check is that do we have compound angles? Do we have compound angles? Now, when we check on this one, this and that, we have a square identity here. We have got a ratio which is sine, and we have cos 2 theta. Now, what is cos 2 theta? Cos 2 theta, because of these two, the position of the 2, it shows that cos 2 theta is a double angle. So cos 2 theta is a double angle. Now, when we have a double angle, how do we dissolve this double angle? Now, because the double angle in this case is cos, we need to dissolve this cos to sine, as sine is a dominating ratio. So we can say that cos 2 theta can be written in the form of cos squared theta minus sine squared theta. It can also be written in the form of 2 cos squared theta minus 1. We can also write it as 1 minus 2 sine squared theta. So now, because we have cos 2 theta, it means that we can now dissolve it as 2 cos squared theta minus 1. Sorry, not cos 2, not 2 cos squared theta minus 1. But because the dominating factor is sine, it means that we are going to choose sine instead. We are going to choose sine instead of cos. Now, in place of cos 2 theta, now we're going to write 1 minus 2 sine squared theta plus 4 sine squared theta minus 5 theta minus 4, all equal to 0. Now, if you check from here, we are going to check. We are going to group terms according to the degree of their ratios. So if we check, the first one is 1. 1 minus 4. So 1 minus 4 is minus 3, equal to 0. Then we have negative 2 sine squared theta plus 4 sine squared theta. So the ratio here, the degree of the ratio sine in this case is 2 and 2. It means that 2 and 2, the squared and squared can now be grouped as like terms. So minus 2 plus 4 is 2, but our ratio is sine squared theta. Then we have minus 5 sine theta. Let's rewrite this. Then minus 3 all equal to 0. Now, because we have sine squared, sine, and a constant here, it means that now we can say let sine theta equal to x. So we developed this statement because we want to work this solution as quadratic using quadratic equation. So therefore it means that you've got 2x squared minus 5x minus 3 all equal to 0. So when it's like this, then that is the knowledge that we have from the algebraic equations. So we have algebraic equations. Using the algebraic equations, we can see that we have x equals to minus b plus minus root of b squared minus 4ac, all divided by 2a. So from here, it means that we can say substitute the values of your coefficients, which is this x equals to minus into minus 5 plus or minus 5 squared minus 4 into, and then our a is 2, our c is negative 3. This must all be under the same square root, all over 2 into 2. Then when you press x, when you press this on a calculator, you get negative 1 over 2, or x equals to 3. Now, because we have this, it means that we can now say, remember the above statement which says let sine theta equal to x. So now we can substitute sine theta back where we see x. So it means that we have sine theta equals to minus 1 over 2, or sine theta equals to 3. So theta in this case is going to be arc sine of negative 1 over 2, or theta is going to be arc sine of 3. This one already is undefined because of the whole number there. Now, but with this one, according to the calculator, arc sine of negative 1 over 2 is the same as negative 30. Is the same as negative 30. So here it says theta is equals to negative 30 degrees. But now, be very careful because the angle given there, this angle on its own is negative. And we know that we don't work with negative angles. Therefore, it means that we must take this negative angle, rendering as positive. then it means that we are going to say theta is equals to 30 degrees. And 30 degrees is the smallest, is the acute angle, is our acute angle. Now we are going to check. Okay, here we have a Cartesian plane. But if we check here, it gave us negative. If we check here, it says sine theta must be negative. So question is, if we have cast, this one says all ratios are positive. Only cos is positive in the fourth quadrant. And then in this case, first quadrant, all ratios are positive. But in this case, in the second quadrant, only sine is positive. And in the third quadrant, only tan. That is positive. Now, where do we find sine negative? If we check here, it means that we are going to find our sine. Sine is negative in the fourth quadrant and sine is also negative in the third quadrant. Therefore, we have sine positive here, sine positive there. But in this case, in the third quadrant and the fourth quadrant, we have sine as negative. So it means that this is where we find our solution. Our solution are going to be in the third quadrant and the fourth quadrant. So now, what angle do we have here? We have 0 and 360 degrees. But we have 90 there. We have 180 here. And we have 270 there. So when we have this, now we check. We said that our acute angle is 30 degrees. It means that if I draw a 30 degree here, I must also be able to draw the very same 30 degree in the quadrant where sine is negative. And then here we have the very same angle. But because we already, if we go to the third quadrant, we are jumping 180. It means that we must go there by means of AD. And therefore, it means that it's 180 plus, it's 180 plus 30 degrees. So which we are going to get 210 degrees. This means that our second solution, apart from 30 degrees, is that theta is equals to 210 degrees. Now, if I draw 30 degrees this side, it means that because I've got 360, when I go down with 360, I'm subtracting, but when I go up with 360, I'm adding. So when we say 360 minus 30, 360 minus 30, it means that we are going to have 330 degrees. So if you say 360 degrees minus 30 degrees, therefore we have 330 degrees. So it means that again, our theta is equals to 330 degrees. So it means that even on the third quadrant, we set 180 degrees plus 30 degrees. Our solution was 210 degrees. Hence, we say that this is our angle of theta. And even this side is our angle of theta. So now, our solutions are these. So use the knowledge that you have in writing the solution. It means that we are going to start with this acute angle, 210 and 330, in order for you to write the general solution. So this is when you write plus K multiplied by 360 degrees. So How you write it, you know, but this is the solution that I can give you. Thank you and keep on practicing.